Hi guys, this video is on chapter 6 chemical bonding, combined science syllabus chapter 6 chemical bonding, and there are two types of chemical bonding. One is ionic bonding, the other one is covalent bonding, and this video is on ionic bonding. Let's look at the lesson objective. Describe the stable electronic configuration of a noble gas. So let's look at the noble gas. The noble gas are the elements in group 0. So the first element, the first noble gas element is helium, and it has a proton number of 2. So from the periodic table, the proton number is the top number, which is the number of protons. And if it is an atom, it would be the number of electrons as well. Since for an atom, the number of protons and electrons are the same. So electronic configuration would be 2. Then for argon, the proton number is 18, so electronic configuration is 288. Then for krypton, it has 36. I mean, the proton number is 36. The electronic configuration is no longer 28 blah 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 888, and then so you can only write this 288 something, the electronic configuration 288 something, up to calcium. So let's look at the periodic table. Calcium has a proton number of 20. So for calcium, electronic configuration is 2882. That is for calcium. How about scandium? Scandium is 21. Scandium is 21. So the electronic configuration is not 2883 for scandium. So this is not within the syllabus. So remember, when you write this electronic configuration 288 something, it is only valid up to calcium. Beyond calcium, you are not expected to write the electronic configuration. Okay, how about, for example, gallium? So for gallium, right, same thing. You cannot write 28888 something. So the only thing we need to know about gallium is that since it is in group 3, so its a valence shell has 3 electrons. So it has 3 valence electrons. Alright, same thing for germanium. Ge is germanium. It has 4 valence electron, 5 valence electron. For arsenic, selenium 6, and bromine 7, krypton 8. So for krypton, all we need to know is the last number is 8. That's for krypton. Since it is in group 0, it should have 8 valence electron. So let's say, okay, so these are the noble gases. So for helium, has 2 valence electron. So it is said to have duplet electronic configuration. The rest of the noble gases all have 8 valence electron, and they are said to have octet electronic configuration. So you need to bear in mind what is the meaning of octet electronic configuration. That means it has 8 valence electron. What is the meaning of duplet? Duplet electronic configuration, it means that it has 2 valence electron. So these two are very important terms. Noble gases are stable and unreactive because they have fully filled valence shell. An atom is stable if it achieves noble gas electronic configuration. Okay, one thing you need to bear in mind is that that's basically for the first part, 6.1. Now let's look at the 6.2, forming ions. Describe the formation of positive ions and negative ions to achieve the noble gas electronic configuration. Now you need to know that positive ion is also known as cation, and negative ion is also known as anion. So let's look at how cations and anions are formed. Now we need to know that most atoms are unstable. Why? Because they don't have stable electronic configuration. They don't have noble gas electronic configuration. An example is sodium here. So sodium in the periodic table, the proton number is 11. So sodium atom electronic configuration 281. So 281, 1 valence electron. That is why sodium atom is unstable. So sodium atom is not happy. So what it needs to do is to lose 1 valence electron to form sodium ion, and the electronic configuration is 2,8. Now remember, loses one electron will form positive ion. It's not loses one electron will form negative ion. Now why is it so? So for example, sodium it has 11 proton. Sodium atom, it has 11 proton, right? And since it is an atom, the number of protons and electrons will be the same. So which means that it has 11 electron. Sodium atom has 11 proton, 11 electron. And you should know that proton is positively charged and electron is negatively charged. So there are 11 positive charge, 11 negative charge. That's why for sodium, the charge is neutral. The charge is 0. Now, when it loses one electron, so this sodium ion would still have 11 proton, because proton cannot be lost or gained. And when it loses one electron, it would have 10. When it loses one electron, it would have 10 electron. So 11 proton, 11 positive, 10 electron, 10 negative. So positive is more than negative. That's why this sodium ion is positively charged. Okay, so when an atom loses an electron, it is positively charged. When an atom gains an electron, it is negatively charged. So sodium ion would have electronic configuration of 2,8. So all the atoms of metals, they lose electron and become positive ion. So which are the metals? The metals are the yellow color elements. All these are the metals. It is separated by this staircase. And this staircase, remember, it starts at the border between boron and aluminium. Okay, so just remember, in between boron and aluminium, that is where the staircase starts. Then it would go down. So all the metals, they would lose electron and become positive ions. So sodium ion has octet electronic configuration. Okay, this is sodium ion because electronic configuration is 2,8. Or noble gas electronic configuration. Which noble gas has the same electronic configuration? EC is the short form of electronic configuration. You cannot write this in the exam. Okay, only in the mind map you can write EC. So which noble gas has the same electronic configuration as sodium ion? Now why is it neon? Because electronic configuration is 2,8. So if you look at the periodic table, 2,8 means that it has 2 plus 8, which is 10 electrons, which means that the proton number is 10. So proton number is 10 is neon. Okay, so when sodium loses, when sodium becomes sodium ion, it would achieve noble gas electronic configuration of the previous noble gas, in the previous period. You can see sodium is in period 3. Okay, sodium, okay, this is period 1, 2, 3. Sodium is in period 3. When it becomes sodium ion, it would have the electronic configuration of the noble gas in the previous period. Neon is period 2. Now let's look at the negative ion. Atoms of non-metals gain electron to become negative ion or anion. An example is chlorine. So chlorine, electronic configuration 287. Why is it 287? Because the proton number is 17. So it's 287 electronic configuration. And 287, obviously chlorine atom is not happy. So it needs to gain an electron to form chloride ion with electronic configuration of 288. And this part is very simple. When it gains an electron, it will form negative ion. Why is it so? Because chlorine atom has 17 proton, which means 17 electron. When it gains an electron, the number of proton would be the same, which is 17 proton. Gain an electron, become 18 electron. And proton is positively charged, electron is negatively charged. So electron is one more than the proton. That is why chloride ion has a negative charge. Okay, so when chloride ion 288, right, has octet electronic configuration because the valence, it has 8 valence electron. That's why it's octet. or noble gas electronic configuration. Which noble gas has the same electronic configuration as chloride ion? Which one? So 288 means that it has 2 plus 8 plus 8 means 18 electron. 18 electron. Which element has 18 proton? Argon. So chloride ion, when chlorine atom becomes chloride ion, it achieves noble gas electronic configuration of argon. Okay, so when a non-metal becomes an ion, it will has the same electronic configuration than the noble gas in the same period, because chlorine and argon is in the same period. When a metal becomes an ion, it has the same electronic configuration as the noble gas in the previous period. For example, just now, the sodium and the neon. So take note of that. So metal become ion, same electronic configuration as the noble gas in the previous period. And when a non-metal becomes an ion, it has the same electronic configuration as the noble gas in the same period. Let's look at the next lesson objective. This part is on ionic bond transferring electrons. Describe how an ionic bonds are formed between metals and non-metal. So when ionic bond is formed, right, electrons would be transferred between the metals and the non-metal. So is it from metals to non-metal or from non-metal to metals? Where are the electrons being transferred? Which direction is it being transferred? So let's look at it. Now it's a sodium. Okay, sodium is a metal. Sodium is a metal. Chlorine is a non-metal. So this one metal and this is non-metal. Now, in order to describe how the ionic bonds are formed, you must describe it from the point of view, you must start the description from the electronic configuration. So first thing you need to you need to write about is the electronic configuration. So sodium atom electronic configuration 281, just refer to the periodic table, refer to the proton number. And to achieve noble gas electronic configuration, sodium atom needs to lose an electron. Remember, when you lose an electron, right, it becomes a positive ion. When you gain electron, you become a negative ion. So this part is on sodium. And then this part would be for chlorine. So chlorine atom electronic configuration 287. Okay, so this part is the sodium loses electron, so become positive ion. Okay. Now is a chlorine. Chlorine atom has electronic configuration of 287. So in order to achieve noble gas electronic configuration, chlorine atom needs to gain the electron from sodium atom to become Cl minus. Yeah, this one should be sodium atom. Okay, and so once you have Na plus, sodium ion and chloride ion, electrostatic attraction forces hold the Na plus and the Cl minus together. So when these two are formed, they will be attracted by the electrostatic attraction forces. So this is a very, very important term. And when these electrostatic attraction forces exist, that means ionic bond is formed. So this is how you explain how ionic bond is formed between a metallic element and a non-metallic element. If you want to illustrate it in the form of a diagram, so this would be it. The sodium ion, chloride ion. And remember, always write down the electronic configuration. Always start your description with electronic configuration first. Okay, start with the metal, then after that, the chloride. So to answer the previous question, the electron actually is transferred from the metallic atom to the non-metallic atom. So in this case would be from the sodium atom to the chlorine atom. So become sodium ion and chloride ion. Okay, sodium atom to the chlorine atom. And when you describe this, you don't need to draw the dot and cross diagram for the sodium atom and chlorine atom. Just need to draw the sodium ion as well as chloride ion. So let's look at this question. Describe how the ionic bond in magnesium chloride is formed. So same thing. Start with the electronic configuration of magnesium atom. Then after that, illustrate that magnesium atom is unstable. So it needs to lose 2 valence electron to form Mg2+. Then after that, the non-metal chlorine atom, electronic configuration 287. Again, it is not stable. So it needs to gain an electron. So in this case, your magnesium loses 2 electrons. So you need 2 chlorine atoms to receive the 2 electrons to become 2 chloride ions. Okay, gain 2 electrons to become Cl-. So electrostatic attraction forces hold the Mg2+ and Cl- together. Ionic bond is formed. Yeah, so you have 2 electrons being lost here by 1 magnesium atom. So you need 2 chlorine atoms to gain the 2 electrons to become the 2 chloride ions. So this is the dot and cross diagram. And the last one would be ionic bond is formed between lithium and oxygen. It's the same thing. But this one, it's the reverse of this. This one, the metallic atom loses 2 electrons. In this case, is the metallic atom, which is lithium, loses 1 electron. But the non-metallic atom needs 2 electrons, needs to gain 2 electrons. So you need 2 metallic atoms, you need 2 lithium atoms. Okay, so lithium, electronic configuration 2,1, achieve noble gas electronic configuration, lithium needs to lose 1 electron to become Li+. Oxygen 2,6, so to achieve noble gas electronic configuration, oxygen needs to gain 2 electrons from 2 lithium atoms to become O2-. That's why you need 2 lithium atoms here to lose 2 electrons to form 2 lithium ions. So electrostatic attraction forces hold Li+ and O2- together. So it's the same thing. Very, very similar. So, and because of this, right, your magnesium chloride, the formula would be MgCl2. And your lithium oxide, the formula would be Li2O. Yeah, so that's the difference. One metallic ion, 2 non-metallic ion. This one would be 2 metallic ion, 1 non-metallic ion. Okay, which is basically the next part that we'll be talking about, which is the chemical formula. So this part is on 6.4, chemical formula of ionic compound. Deduce the chemical formula of an ionic compound from the charges on the ions and vice versa. Now, so in order to get the formula of an ionic compound, you need to get the formula for the metallic ion as well as the formula of the non-metallic ion. So this part would be the metallic ion. See, positive ion, mostly metallic. Sodium, magnesium, aluminum, hydrogen, all this, you can actually get it from the periodic table. So you don't need to go and memorize, sodium ion, the formula is Na+. Magnesium ion, the formula is Mg2+. No need. You can get it from the periodic table. And the thought process is, first thing is to find out which group the metal is in. For example, magnesium, which group? So you can actually refer to the periodic table. Magnesium, it is in group 2. Now, what's the meaning of group 2? Group 2 means what? Group 2 means 2 valence electron. And 2 valence electron means that you need to achieve 8, right? 8 valence electron. So 2 valence electron means that you need to lose the 2 electrons to achieve noble gas electronic configuration. When you lose 2 electrons, remember, it will form an ion of charge 2+. That's why the magnesium ion, the formula is Mg2+. Likewise for aluminium, you don't need to remember aluminium ion, the formula is Ag2+. All you need to do is to find out which group refer to the periodic table, which group the aluminium is at. is it is in group 3. So group 3 means 3 valence electron. 3 valence electron means you would need to lose 3 electron. To achieve noble gas electronic configuration, lose 3 electrons means that the charge is 3 plus. That's why it's Al3 plus. So all this refer to the periodic table except this. This one you need to remember zinc. Where is zinc in the periodic table? The zinc is here. Zinc is here. There is no group. That's why for zinc, you must remember that the zinc ion, the charge is Zn2 plus. Silver, where is silver? Silver is here. And again, there is no group. So zinc and silver, you need to memorize the charges. Now, how about all this cadmium, gold, mercury? All these, they are not in the syllabus. No need to bother about their charges. So zinc, remember 2 plus, Zn2 plus zinc ion, silver ion, Ag plus. Must remember. And likewise for copper. Copper is a bit special. Copper also no group. Copper is a bit special because it can form more than one type of ion. But in our syllabus, it's mainly copper 1 or copper 2. And the charges are basically in the bracket. They will tell you the charges. So when you see copper 2 sulfate, for example, the copper 2 means that it's Cu2 plus. Likewise for iron. Iron also no group. Iron can form iron 2, iron 3. And again, which one is it? It is given to you. Iron 2 means Fe2 plus. Iron 3 means Fe3 plus. So you will, the charges are actually represented or denoted by the Roman numeral in the name. Okay, ammonium. This one cannot be found in the periodic table. This is called a polyatomic ion. Polyatomic means consists of more than one atom. So ammonium ion, you must remember NH4 plus. So all this, so for the positive ion, you need to remember zinc ion, silver ion, as well as ammonium ion. The formula, you have to memorize the formula. Now, how about negative ion? Now, negative ion, the non-metal ion, chloride, you don't need to memorize chloride ion. The formula is Cl minus because again, you can refer to the periodic table. Chlorine is in group VII. VII means 7. Chlorine VII, so group 7. So group 7 means what? 7 valence electron. 7 valence electron, you need to get to 8, right? So 7 get to 8, pretty near. So that's why you just need to gain 1 electron. When you gain an electron, to achieve noble gas electronic configuration, the charge of the ion will be 1 minus. Okay? Oxide, same thing, group 6. So oxide ion, you don't need to remember the formula because oxygen is in group 6. Group 6 means 6 valence electron. 6 valence electron means needs to gain 2 more electrons in order to achieve noble gas electronic configuration. So the charge of oxide ion is O2 minus. Nitrite is from the word nitrogen. Nitrogen, group 5. So need to gain 3 electrons. So N3 minus. Hydride. Hydride is from hydrogen. Now hydrogen actually can form either H plus or H minus. It can gain 1 electron or it can lose 1 electron. So when it loses 1 electron, that is when it will form hydrogen ion H plus. When it gain 1 electron, it will form hydride ion H minus. So the question would tell you, most of the question would tell you whether it gains or lose, but most of the time, hydrogen atom would lose. Would form hydrogen ion, which is H plus. Most of the time, it would be hydrogen ion H plus. Now, for these polyatomic ions, you must remember the formula because they cannot be found in the periodic table. Hydroxide ion OH minus, nitrate NO3 minus, carbonate CO3 2 minus, hydrogen carbonate HCO3 minus, sulfate SO4 2 minus, phosphate. This one is only for pure chem. So if you are not taking pure chem, you do not need to remember phosphate ion. Okay, can't get from periodic table, so must remember. Now, one thing to take note is that the name of positive ion is the same as the name of the atom. For example, sodium atom. Now is sodium ion. So both are sodium. Magnesium also. Magnesium atom, magnesium ion. So when the atom become a positive ion, right, the name doesn't change. Sodium atom, sodium ion. But for the negative ion, the name does change. For example, Br is actually bromine atom. Br minus bromide ion. Likewise with sulfur, S sulfur atom and S2 minus sulfide ion. So when you see the suffix, okay, the last three letters is IDE or ATE. That means it's trying to hint to you that it is a negative ion. See, all these it has IDE or ATE. See, all these are IDE, ATE, 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 ATE. So which means that they are negative ion. So in order to get back to the lesson objective, in order to deduce the chemical formula, first step is to, the chemical formula of an ionic compound. The first step is to find out the chemical formula of the positive ion as well as the negative ion. Once you get the formula of the negative ion and the positive ion, step 2 will be to cross multiply the charges. So for example, magnesium ion, Mg2 plus, chloride ion, Cl minus. You cross multiply. Cross multiply means you take the number of the charges and then bring it down. So this 2, you bring it down to Cl2. And this one is 1 minus, right? You bring the 1 down to Mg1. And for chemistry, if it is 1, we do not write. That's why it's MgCl2. Now, how about this calcium oxide? So MgCl2 is magnesium chloride. How about calcium oxide? So calcium ion, Ca2 plus, oxide ion, O2 minus. Okay, oxide ion is here. O2 minus. So you bring the 2 down here. The 2 down here becomes Ca2O2. So Ca2O2, it can be simplified. It must be in the simplest form. CaO. Okay, of course, this simplest form rule, there is some exception. An exception will be hydrogen peroxide, H2O2. Yeah, H2O2 remain as H2O2. It is not HO. Okay, and also when you write the chemical formula of the ionic compound, you have to bear in mind that you have to write the positive ion first. Mg must come first. Cannot be the negative ion first. Must be positive ion first. And the third one is copper 2 hydroxide. See, copper 2. So it's Cu2 plus. The 2 basically means the charge. Cu2 plus. Hydroxide, you have to remember OH minus. So you bring it down, the 2, put it here. Okay, now remember this polyatomic ion. Polyatomic ion is together one. So when you bring the 2 down, right, this 2 belongs to both O and H is together. So that's why you need a bracket. So if there are more than one polyatomic ion, you need to use a bracket. You cannot put just OH2, because if you write like this, basically what it means is that this 2 belongs to hydrogen only. But polyatomic ion is together one. So you must put a bracket. This 2 belongs to H as well as O. Alright, let me summarize how do you write the chemical formula of an ionic compound. First step, must get the formula of the positive ion and the negative ion. And some of them you need to remember, like for example, zinc, silver, polyatomic ion, all this you need to remember. Because all this cannot be obtained from the periodic table. And after you got the chemical formula of the ionic, positive and negative ion, all you need to do is to cross multiply them. And when you cross multiply them, just bear in mind, you need to express it in the simplest form. There are some exceptions. And also when it comes to polyatomic ion, you need to put a bracket if there is a 2 or 3 or 4 outside. Okay? You need to put a bracket because polyatomic ion, the atoms they are actually together one, so you need to put a bracket here. So these are the practices. Write the chemical formula of the following substances. Potassium chloride. So same thing, if you want to write the chemical formula for potassium chloride, first thing, potassium ion, look it up in the periodic table, group 1, so it's K plus. chloride Cl minus, cross multiply, this is 1, KCl. For chemistry, we do not write. You cannot write 1, 1 here. Okay, copper 2 nitrate. So copper 2, Cu2 plus, nitrate, NO3 minus. How do you know nitrate? Nitrate you need to memorize, NO3 minus. And when you cross multiply, so Cu, NO3, must put a bracket and then 2. Cannot be Cu, NO3, 2. This one becomes 32 already. Okay, iron 3 carbonate. Iron 3 is Fe3 plus. Carbonate is CO3 2 minus. Over here, carbonate CO3 2 minus. And when you cross multiply, it will become Fe2. Okay, 2 down here and CO3 again, polyatomic ion, you need to bracket it. And finally, ammonium, NH4 plus. Where is ammonium? It is here. And bromide. Bromide is in group 7, so it's Br minus. This one, no need to cross multiply because 1 plus 1 minus balance out NH4 Br. Okay, as well as this table here, it's pretty straightforward, similar to what I said. Formula of the cation, anion, and then just cross multiply, and that would be the answer.